In this video, I'm going to share with you a really simple and easy to understand method to find the determinant of a 4x4 matrix. And there is a kind of magic trick that we can do that makes life much, much simpler. So if we've got a matrix that looks like this, so we've got a diagonal here, and we've got all of the elements below the diagonal as 0. This is what we call a triangular matrix, specifically upper triangular. So when you have all of the elements below the diagonal as 0, you've got an upper triangular matrix. And these have a fantastic property, which is that their determinant is simply the product of the diagonal. So if you do 2 times minus 1 times 2 times 1, you get the determinant, which in this case is going to be minus 4. So that's fantastically simple. For a triangular matrix like this, you can just look at it and you can tell the determinant. Unfortunately, not absolutely every single example or question that you will get is going to be of that form. But what you can do is manipulate the matrix to be in that form so you can use this beautiful simple property. But when you're doing it, you have to be aware of two rules. So the first big rule is that row and column operations do not change the determinant, but interchanging rows and columns changes the sign of the determinant. So if you do something like row 2 becomes row 3, so you've swapped those two, the sign of the determinant changes. And so the flipped matrix where you've swapped rows is going to have a determinant that's got the opposite sign to the matrix you're interested in. So you have to keep track of it so you get the right final answer. So let's look at an example. So we're going to find the determinant of this matrix. And there is nothing special about this matrix, though it's not in our triangular form, which is quite annoying. So if you were to take the product of those diagonals, you'll get the wrong answer. What we need to do is, you see all those numbers that fall in that triangle, they need to be 0. So we have to manipulate this matrix so that all of this becomes 0. And once we've done that, we can use our beautiful diagonal property. So let's see how you do that. So we've got this matrix here, and I'm going to put a plus sign above it. And that's just my way of saying that I don't need to do anything to the determinant. So the determinant of this matrix is the determinant that's the answer, because this is our question. However, if we do any swaps of rows, for example, then I'm going to change that to a minus to say I need to remember to change to the determinant at the end or I'll get the wrong answer. So this is not in the form that we want, so we have to think about how to do that. And the first thing that stands out is this bottom one here, where we've got this 4 and the 2. So what we can do is we can say that row 4 becomes row 4 minus 2 row 3. So we've got 0 minus 2 times 0, which doesn't change anything. 4 minus 2 times 2. When you do that, you get the 0 there as desired. And then you're doing 2 minus 2 times 1, which gives you the 0 as desired. And then 3 minus 2 times 1, and you end up with this. And you can see that the bottom line now looks kind of like what we need for our triangle. We need this 1 staying on the diagonal and everything else 0. So we're trying to go for this triangular shape. The next step is to keep track of this. So we're saying it's positive because we've not done any row swaps. So there's nothing to change the determinant. So this is exactly the same. So what I'm basically saying is that the determinant of this matrix and the determinant of this matrix are the same. So let's look at the next step. So I'm going to do row 3 and row 2 are going to swap. So this row is going to become here, and this row 2 is going to become here. So that's the result. Nice, simple swap. However, this is our rule number 2. It's now got a negative determinant. So the determinant of this matrix is the negative of the determinant of this matrix. So the sign of the determinant has now flipped. We now are slightly closer to our final answer, because this 0 is in the right place, these zeros are all in the right place, but this row is a bit annoying. This row just isn't what we want. And so we have to do something to sort that out. And when you think about it for a while, you'll see that row 3 should become row 3 minus 3 row 1, for example. 3 minus 3 times 1 gives you 0. And so we now have it in the right form. So we started with a matrix we didn't like, that we couldn't use the nice property. And then we've turned it into a matrix that has this nice property and is in upper triangular form. And I'm going to put this negative here because Again, the determinant of this matrix is the opposite sign to the determinant of this matrix. We actually only care about the determinant of this matrix because that's the question. So to find our final answer, we're going to work on this matrix, and we're going to take the determinant of that matrix, but I've put this big bold negative in front of it. So the determinant of this matrix, we have to change the sign. And obviously we find the determinant by doing 1 times 2 times 2 times 1. And then we have to swap the sign of that. So we end up, when we do that product of diagonals, with the determinant as -4. And that's our final answer. So hopefully you found this video helpful. And finally, thank you very much for watching.